My fabulous chemistry students, video 8, woohoo! Last one of the unit. So, today it's a molecular formula. It's going to be a compound of empirical formula. Basically, it's going to be what it really does exist as in nature. So the expanded version from the empirical formula being it in those little packets. So we can basically expand. So determining molecular formulas, so far we know how to find an empirical formula from last video, from percent mass, or from the molecular formula. But how do we find out the molecular formula from an empirical formula? So that's what we got to be able to do today. And again, the same thing. I have a compound that is 80% carbon and 20% hydrogen by mass. If its molecular mass is 75, what is its empirical formula? What is its molecular formula? So here's the new piece. The new piece is the total mass of that molecule is 75 grams, okay? Or of the, of the compound. So what is the molecular formula? So first we have to do everything we had to do to get the empirical formula. Sorry for all that extra noise. 80% becomes 80 grams. 20% becomes 20 grams. Now I need to divide through by the masses. I'm going to take 80 grams and divide by 12 for carbon. I get that 12 off my periodic table. So I have 80 divided by 12 equals 6.7. And now 20 divided by 1 is going to equal 20. Now what I need to do here is make my ratio 6.7 to 20. So let me divide that number by 20 and see what I get. I get 0.3. So it's basically 1/3. This one is 1/3 of this. Does this make sense? 6.7 is 1/3 of 20. So my ratio is 1 to 3. Okay. So let's see. I need my empirical formula now to be C1H3. Okay, then let's see if that makes sense. Let's just double check ourselves. Convert to grams into moles, have grams needed moles. So all right, so I did this. I converted to grams and then to moles. And I did this all right in there. I took step 1. This is step 2 here. This is step 2. I did it right in there. Sorry about that. And I came up with that empirical formula. Yep, by the smallest mole number and round to the nearest integer. Okay, so, Mr. Milks, that means the 6.7 and 20. What I'm supposed to do is say 6.7 divided by 6.7 equals 1. And then 20 divided by 6.7 equals, and it's going to be approximately 3. 20 divided by 6.7 equals 2.98, which is basically 3, which, like I said, is a 1 to 3 ratio, or 1/3. But so now this is the coefficient, or I'm sorry, the subscripts, and so I get C1H3. So I'm sorry I jumped ahead, but sometimes I get a little goofy, pretty highly caffeinated. You know what I mean? Just how it goes, man. So now we can determine the molecular formula. So the empirical mass, if I figured it out, it's CH3. We're good there. So what is the mass of this? The mass of CH3 is 12 plus 3, which is 15 grams. Okay? It said my molecular mass was 75 grams. So now it says the molar mass, or the molecular mass, is how many times greater? Well, let's do that. Let's do 75 divided by 15 and hope it goes in pretty even. It's 5 times greater. So now the molecular formula must be 5 times larger than the empirical formula. So basically, I'm going to multiply all my subscripts by 5. So here's my initial empirical formula, C1H3. If I multiply all the subscripts by 5, that's going to give me up here C5H15. Now this is the molecular formula expanded. Okay, and I can do that. What I need to know is that these empirical formulas are going to come in chunks. basically is what's going to happen. Now, how many chunks do I need to get to 75 grams? Do I need 5 chunks? Do I need 4 chunks? Do I need 6 chunks? And I had to figure that out by taking this number and dividing it by this number. Once I have the empirical formula, we're good to go. So let's do one more for practice. I will do one and you'll do the rest. That's how it works. So here we are. I will do, all right, so this one is, I'm not going to do one. I'm going to do two with this 50% business. So if I got 50% sulfur, if I assume 100 grams, I have 50 grams of sulfur. Let me just do oxygen real quick. I'll switch colors. 50% of oxygen goes to 50 grams of oxygen. I need to look up sulfur's mass. I know oxygen is divided by 16. And sulfur's mass, I got to divide it by 32. Right? So I'm going to say 50 divided by 32. By 32. 1.56. Switch to blue, Mr. Milks. 50 divided by 16. 3.125. Then basically this next step, I can divide these two numbers by each other, but the easiest way is to get this to this lower number to 1. What I do is divide both ones by the lowest number. That's going to ensure that this number goes to 1. And then I'm going to hope that this number comes to something that's remotely a whole number. All right, so this is obviously going to be 1. Now I'm going to say 3.125 divided by 1.56 equals beautiful, 2. So here's my subscript on my sulfur. Sulfur is 1, oxygen is 2. And now it says find its molecular mass. Well, so what I need to do is find my empirical mass. So if I got SO2, this molecular mass here, or this empirical mass, if you will, I'm sorry, is going to be 32 for sulfur plus 32, which is 2 oxygen. 16 times 2 is 32. Yep. And that's going to be 64 grams per mole. Oh, no. Okay. Now, if I have 128 grams total in my molecular mass, let me divide that by 64. So, look, it's 2. So now I need to go back and multiply everything here by 2, so it becomes S2O4, my molecular mass being that it's 128 grams. Bet. So here's some more for you guys to work on. I'm going to let you guys do this for full credit. Of course, you can complete now just page 32, and you do have a Castle learning assignment, which is 5 questions in Castle. And best of luck to you. We are done in under 8.5 minutes. Peace out. Unit's done, except for all that other stuff on your checklist. Ready?